Hey folks, welcome to Hot Takes and Cold Storage. I'm your host Nate. Today we're going to talk a little bit about Microsoft, then I'm going to mispronounce Forgejo a whole bunch of times. Then we're going to talk about some privacy-focused laws that have made some progress, then a cool project that brings some new life to your old Google Home Minis, and some very embarrassing news out of CISA. And then we're going to deep dive into a supply chain attack that personally I hadn't heard of until I started prepping for this show. If you haven't, then you're going to want to stick around for this one. So, Microsoft, in their decades-long crusade against their own users, quietly added Copilot as a co-author on Git commits if you're using VS Code. Now, this happened even if you have all the AI-assistive technologies inside of VS Code turned off. And of course, after an outcry from VS Code users, Microsoft pretty quickly patched this, claimed it was a mistake, and moved on. Personally, a long time ago, I switched to VS Codium, which is a de-Microsoftized, fork of VS Code. You almost can't tell the difference. All right, now prepare yourselves because I am about to mispronounce the name of this project, Forgejo, several times within this article. First, for those of you who don't know, Forgejo is a fork of the project Git, which I also don't know how to pronounce. The Dutch government, however, has decided that hosted solutions for code repositories for their own internal things are no longer good enough. They want to own their own data. They want to own their own platform. And to that end, they've launched their own Forgejo. I don't know. Somebody tell me how this is pronounced. Anyway, they've launched their own Forgejo code repository. This is a digital sovereignty move, which this is becoming more and more popular within the IT industry pretty much around the world, as more and more nations have decided that they just can't trust data that's hosted outside of their country's borders for lots of reasons. I mean, just look around at the instability in the world today. People are worried, right, that all of a sudden access to their own data is going to be cut off because of some weird trade dispute or some crazy tariff that gets thrown at them. Side note, I never really thought that my IT career would lead me to a position where I had to spell the word sovereignty frequently throughout a given day. So there's that too. Moving on. Many states in the US are starting to implement their own privacy rules, their own privacy laws, because there's pretty much a complete lack of any initiative for privacy laws at the federal level. And I've got a couple of articles linked in today's show notes that will give you kind of a summary of kind of the progress of a bunch of those laws. A couple that I wanted to call out was California's AB 2561 is recently passed. This prohibits your operating system or your apps from resetting the privacy settings after you've set them. So when an operating system asks you for privacy settings and you tell it one way or the other, it can't go back and change that because it felt like it, which has happened in the past. Now it's against the law, in California anyway. In other news, Connecticut has recently passed a bill that requires data brokers to register with the state, which I don't know if they have to go through some sort of an exam. Will you sell my data? Will you keep my data? I don't know the details here, but I think it's neat that they're actually thinking about this, that data brokers are going to have to be registered with the state now. So that's pretty cool. But again, only in Connecticut. I really feel like there should be federal level laws for these things, but here we are. So like I said, there's, I think, 2 articles in the notes today that outline the progress of many other laws. And if you're really interested in the subject, you should go check them out. All right, I really love this next one. If you're like me, maybe when you got into home automation, you saw the Google Home Mini as a really inexpensive sort of voice assistant that you could put everywhere in your house so that you could have it talk to Home Assistant. Yeah, that's me. I've got Google Home Minis everywhere. Like I can't say the word Google anywhere without something triggering. If you did do that, you're probably finding, like me, that those Gen 1 Google Home Minis are more and more turning into bricks. They get less and less useful because as software updates come and as capabilities get stripped away from them, which seems more and more common, in my opinion, they're just getting more and more frustrating to deal with. But there's some good news. There's a project from MiciMike, I think that's how you pronounce it, M-I-C-I Mike, that might just change that. They're producing a drop-in replacement for the control board inside of the Google Home Mini Gen 1 that turns it into a Home Assistant voice. I mean, that's pretty crazy, right? The Home Assistant voice runs on a little ESP chip, and they have a custom printed PCB that fits perfectly inside of the Google Home Mini. And then it connects, I suppose, to the existing speaker and microphones so that you get a similar experience from a audio level, but you're using completely self-hosted local voice assistants instead of something that has to send your voice off to the cloud every time you trigger the damn thing. Now, I've got a Home Assistant voice preview kit, and I'll admit that it isn't exactly perfect. It's got some rough edges. It doesn't have the polish that the Googles and the Amazons and the whatevers do, but it is pretty darn slick, and it is pretty darn capable, and you can link it up to either a local or cloud-hosted LLM. So if you want to go further than just turn on my lights or, turn off my air conditioner, you can. You can actually have it interact with an LLM to give you real-time, thinking answers instead of just the local integration with Home Assistant, which I think is pretty cool. I have it tied into a local LLM that I run in my home lab, and it's not quite as snappy as the cloud-hosted things, but still, it's pretty darn cool that it's all owned by me. It's all running locally. In the links for today's show, you're going to see a link to both an article that talks about the project and a link to Crowd Supply, where you can back the project. I know I have. Okay, one last article before we get into the deep dive, and buckle up because this one is fire. Have you heard of CISA? CISA? It's a government agency, and they're the Cybersecurity and Infrastructure Security Agency, literally responsible for defending the U.S. government and its networks against cyber attacks. So the irony won't be lost on you when I tell you that a government contractor working for CISA stored a veritable treasure trove of access credentials and procedures on a GitHub repository. Stop me when you've heard this one. We're talking about AWS GovCloud admin credentials, a CSV export of Firefox passwords for dozens of internal systems, and a detailed documentation on how CISA builds, tests, and deploys its software. You might say, hold on, I've accidentally pushed passwords to GitHub before. It warns you, it sees them, and it says, hey, you should scrub this thing, and then you should change that password. Yeah, well, that only works if the government contractor didn't turn the dang thing off. Yes, the government contractor turned off the security warnings because obviously, how am I going to store my password hives on GitHub if this pesky security setting is getting in my way? And then on top of that, they made the repository public. That's right, for 6 months, the repo was public. The repo has since been taken down, and no word on whether the credentials were used for anything nefarious in the 6 months. 6 months that the repository was public. All right, folks. So the next one, we're going to go into, I guess you could call it cold storage, the cold storage part of the new title for my new show. Folks, I also wanted to say thanks for tuning in. I know I've been absent for a little while. Things have been a little bit crazy with work. It was Red Hat Summit season. That means I have a bunch of deliverables and deadlines. Those are past, and I really want to get back to making this show on a regular basis. I'm aiming for every 2 weeks, so hopefully every other week you'll be able to be treated to my hot takes and these deeper dives I'm calling cold storage. So remember to like, subscribe, do all the things you liked for YouTubers that you like to watch often. And yeah, let's cut on into it. The date is May 11th, 2026. Over 170 packages compromised across NPM and PyPI in a single coordinated attack. 84 malicious versions across 42 TanStack packages published in a tiny 6-minute window. But it goes further. The campaign also hit Mistral AI, UiPath, OpenSearch, and more. This is the first documented supply chain worm to ship with valid security provenance certificates. Let's talk about how it happened and maybe what we can do to try to help stop it in the future. First, what's TanStack? All right, so TanStack is a popular collection of open source JavaScript libraries. Their React router alone has 12 million weekly downloads. They're used widely in web development. If you've used a modern web application lately, you've probably used their code, whether you know it or not. The other projects that I mentioned there in the intro, Mistral AI is, of course, an AI company. They make the Mistral LLM. UiPath is an automation tool, and OpenSearch is a community-driven fork of Elasticsearch. This isn't some niche little library that only half a dozen projects consume. This is the core framework that a huge chunk of the web utilizes. So what happened? All right, so the attacker created a fork of TanStack/router using a throwaway GitHub account and exploited a known dangerous pattern in GitHub Actions called the pwn request. So what's a pwn request? Let's go down that rabbit hole, right? GitHub Actions have essentially two workflow triggers. So there's the standard pull request trigger, and then there's the pull request target trigger. Pull request is generally safe. This is kind of the most common way that this operates. When someone from outside opens up a pull request against your repo, this runs the workflow in the context of the external repo, right? Of the forked repo, not the main repo, with no elevated permissions. It doesn't have access to any secrets or tokens or caches. But pull request target is different. This exists to solve a legitimate problem, right? So this isn't in itself a vulnerability or a flaw. Running a workflow that does require elevated access when a pull request comes in. Basically, if things need to write a token to the repo or something else that requires more permissions, this one runs in the context of the base repo, and it has full access to secrets and caches. Pay attention to that because that's going to be important later. The issue here is that the workflow's definition comes from the repo's default branch. This is fine. This is the way it's supposed to work. The attacker can't actually modify the workflow itself, but if the workflow contains a step that checks out the pull request's code and then executes the code, like if it runs a test or if it builds or if it runs a script, something like that, now that code is running inside of the base repo's elevated permissions. So it's running inside of the repo, inside of that context. This isn't a bug exactly, even though it sounds like it could be one. It's more like a feature, but when that feature is used, it creates a little bit of risk and it needs to be accounted for. GitHub can't simply remove pull request target because legitimate workflows depend on it. The action itself isn't really dangerous. What maintainers allow inside of the workflow is, however, if the workflow checks out and runs code from that pull request, that's where the problems start. It's not a platform flaw, it's a choice. GitHub, in fact, has taken steps to help developers protect against this, and they've issued things like best practices and even warnings about what you should and shouldn't do when you're using this pull request target workflow. And in this case, the code that it executed wasn't even all that obviously malicious, right? It didn't do anything blatantly terrible. So it's easy to see that it could pass code review. All it actually did was poison the GitHub Actions cache for that repo. Then basically what happened next was whenever a legitimate maintainer merged in their pull request, then the release pipeline would restore that poisoned cache and boom. Attacker code executed within the elevated permissions of that repository. What it did was extracted authentication tokens directly from the runner's process memory, and it used those tokens to publish more malicious packages through TanStack's own legitimate release pipeline. Now, pay attention to that too. No credentials were actually stolen here. No accounts were phished or compromised. Multi-factor was enabled for all the maintainers. But none of that actually mattered. The malicious package passed every security check and even the SLSA provenance verification. Essentially, this means that the packages that came out of the other end were verified, signed, and implicitly trusted. SLSA, by the way, or SLSA, is the supply chain levels for software artifacts. These are the standards that say that we can trust this package, right? It basically says that I wrote this package, I built this package, I say that it's clean. So this isn't necessarily a flaw in GitHub. It's like having a secure building where you've got guards at the front door, and those guards check IDs on the way in. but you've also got a side door that's used for package deliveries. And that side door uses like a key card or something so that your employees or your package deliveries can open that door to bring in a package. But then someone slips a malicious package into the deliveries. So it all goes through the security checks and it gets into the building. That's not a flaw in the way the door works. It's not a flaw in your keycard access. It's a flaw in the way you've checked the validity of packages coming in. So what did this worm actually do? We talked about how it propagated itself, but that in itself really doesn't do anything other than be annoying. Obviously, there's going to be some malicious code at play here, right? So here's what it did. And this is really sort of a kicker. When someone installed one of these infected packages, the malicious code executed via NPM lifecycle hooks. It stole GitHub tokens, NPM tokens, cloud provider credentials, Kubernetes tokens, and Vault tokens. So pretty much everything it could get its hands on. Then it identified other NPM packages that the victim could publish to and injected itself into those packages and published them. Each compromised developer or continuous integration runner became a new vector for infection. It even installed a persistent daemon called GH Token Monitor that polled GitHub every 60 seconds. And this is the real kicker. If you revoked your GitHub token, which is pretty much standard practice, right? You realize something's amiss, you revoke your GitHub token because that's exactly what you're supposed to do. Well, the vindictive little thing erased your home directory if it detected that you revoked your GitHub token. So obviously we wouldn't be talking about this if it didn't get noticed, and it did in fact get noticed pretty darn quickly. So let's talk about what the detection and response looked like. In under 30 minutes, the articles are saying between 20 and 26 minutes. I guess it depends on the release cycles and whatnot of the various packages that were infected. The worm was detected by an external researcher at Step Security. All of the affected versions were deprecated, and NPM security was engaged to pull down the released tarballs from the registry, and TanStack themselves published a thorough postmortem and hardening post afterward. The key takeaway here is that all the security mechanisms worked. Everything was in place. They did as much as they could right, and it still didn't stop this attack. TanStack has restructured their workflows. They don't execute fork code anymore, and they've taken other measures. It's all outlined inside of that after action report that they published. And of course, I'll include a link in the description of the show to their postmortem so you can go read it. So in summary, I mean, what can I say here? This supply chain attack is an eye-opener, right? It's not a story about TanStack messing up. I mean, sure, they didn't have to execute that external code, but again, this is something that is common. It's a thing that people do. Otherwise, this pull request target action wouldn't even exist. They did as much as they could right, but no matter how high the bar is set, the attackers just find a way to jump higher. The great story here, though, is the response. Step Security catching it quickly, TanStack publishing a detailed postmortem, the community rallying to harden workflows. That's all open source working as designed. The community identified the problem, responded quickly, and most importantly, they shared what was done out in the open. That in itself is a success, but it's a good reminder that security isn't just a checklist. It's an ongoing battle, and the bad guys keep evolving faster than the frameworks. All right, that's it for today's show. Thanks for watching, and I hope you tune in for the next one. If you like the format, the new name, whatever, give me some feedback. Let me know what you think. And yeah, I'll catch you in 2 weeks.